Hi, and welcome to my video on arithmetic sequence part 3, and this video is about linear function, being a linear function. Okay, we have a sequence which is 3, 5, 7, 9, dot, dot, dot. So again, this is 1, 2, 3, 4. So this first, second, third, and fourth term, etc. And this is T1, term 1, term 2, term 3, term 4. So we say that this is n, because these are the n's, 1, 2, 3, 4 terms. This is Tn down here. So we put that in a table, we get 1, 2, 3, 4, and we get 3, 5, 7, and 9. Notice that T1 is 3, and if we work out the difference, we have 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2, so D1 is a 2 difference. Let's have a look at plotting that arithmetic, which is going to be a linear, arithmetic. So this is n, and this is Tn. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. So just a number, make sure. So 1 gives me a 3. X is 1. N is 1. I got to be careful with X and Y's. N is 1. Tn is 3. N is 2. Tn is 5. N is 3. Tn is 7. Right there. N is 4. Tn is 9. There we are. And notice it's forming, the dots are forming a line going through here. So we want to find the equation. So we'll write down that Tn equals T1 plus n minus 1 times d. So T1 is 3, n minus 1, the difference is 2. 3, 2 times n is 2n. 2 times negative 1 is negative 2. So Tn is 2n. 3 minus 2 is 1. Now, let's look at it. We took the table of values and we plotted it. Find the slope from the graph. So notice we're leaving here and we're going 1 up, 2, right 1. So we're going up, that's the rise, over the run, up and to the right. So it's the rise over the run. So we're going up, 2, right 1, up, 2, right 1, up, 2, right 1. So the slope is 2 when we look at the graph. We go up, 2, right 1. Rise over run, which is up, 2, right 1. Up is positive, to the right is positive, so the slope is 2. Now we do the slope from the table. We remember that n and Tn are the coordinates of the points. So when we have 1, when n is 1, the t of 1 is 3. And when we have n is 2, so the t of 2 is 5. So from the table, the slope is y 5 minus the 3 over the 2 minus the 1. So that's 2 over 1 or 2. So the slope is 2, which is going to be the same as if we did the graph, or the same from the table. So that means that D1 is 2, A is 2, and the slope is 2, because D1 is equal to A, which is equal to the slope. Notice A is 2. The difference, D1 is 2. The slope is 2. So that means in this table, if if I do the differences, 9 minus 11 is negative 2. 7 minus 9 is negative 2. So the difference, D1, is negative 2. A is negative 2. The slope is negative 2. Notice that in this equation, which represents an arithmetic, and notice an arithmetic is a linear function, so we have A is 4. So that means D1 is going to be a 4. That means the slope of this graph is going to be a 4. And now we have a graph. So this graph going from one, notice the graph is going down. So we go 1, 2, 3. So we're going the rise over the run is down 3. And we're going right 1. So that's negative 3 over 1, or negative 3. So the slope of this graph is negative 3. That means the difference in the equation is going to be negative 3. That means the difference in when you set up the sequence is going to be A is negative 3. Let's continue. So D1 is the slope. Okay, let's look at Tn is negative 2n plus 8. A is negative 2. D1 is negative 2. The slope is negative 2. So let's make a table of values. When n is 1, put a 1 in. Negative 2 times 1, negative 2 plus 8 is 6. Put a 2 in. Negative 2 times 2, T2, n is 2. Negative 2 times 2 is negative 4. Negative 4 plus 8 is 4. And we're going to put a 3 in. Negative 2 times 3 is negative 6 plus 8 is 2. Again, notice we're going to have a look at the graph. This is n and Tn. N is 1 and Tn is 6. N is 2, Tn is 4. N is 2, Tn is 4. That's 6. 4 is right here. When n is 3, Tn is 2. As you can see, it's coming down, and the slope is negative 2. It's down 2, right 1. Down 2, right 1. When I say down 2, it goes 1, 2, right 1. Down 2 from here, 1, 2, right 1. An arithmetic sequence is a linear. Notice it's a linear function. And notice why I'm just going to compare Tn equals 2n plus 8. Notice that the power of n is 1. And that means it's very similar to y equals mx plus b. Notice that's a line. And that power is 1. This power of n is 1. So this is a linear. Notice again, the degree of this equation is 1. The degree is 1. And it's a linear. And that's very similar to y equals mx plus b. So a linear sequence, an arithmetic sequence is a linear function because the dots form, notice the dots form a line. In any sequence, the values of n are 1, 2, 3, 4, etc. That means n belongs to the natural numbers. The domain of an arithmetic sequence is the set of all n, so set n belongs to the natural numbers. Any arithmetic sequence, any sequence, the domain is always n. Now let's look at the range. The range, which is the Tn of any arithmetic sequence, can be represented by. So we've seen this in earlier videos, way back when we were dealing with real numbers and the system of real numbers. This is the set of all Tn such that this is the equation of the sequence and n belongs to the naturals. This is how you can't name all the ordered pairs that's in this sequence. So notice, because the sequence goes on and on and on, So it's the equation that will represent the values of the range. So in this case, right here, we have Tn such that Tn equals a n plus b, where n belongs to the integer. So because we have an arithmetic, the equation of the arithmetic is Tn equals a n plus b. So what we're going to do now is that I'm going to work out these equations so that I can find the range. And we have an arithmetic sequence, which is D1. We're saying they're arithmetic. So Tn equals T1 plus n minus 1 times d. So T1 is 7 plus n minus 1 times 2. 7 plus 2n minus 2. 2n plus 5. So that's my equation. So what's the range? The range is a set of all Tn's such that Tn equals 2n plus 5, where n belongs to the natural numbers. And that's how you write down the range. Again, a lot of people don't stress the range due to domain, but the range can only be. So as a result of having whatever n is, so when you put n as 1, then you get a 7. When n is 2, you get a 9. When n is 3, you get 11. And so on, so on. So for all the values of n, then all these values here are the range values. As you think of domain as x, which is similar to the n, and the range is the Tn, which is similar to the y. Now this question here, we have to go and find. We know what T1 is. T1 is 16, but we need to get the differences. So 12 minus 16 is negative 4. 8 minus 12 is negative 4. 4 minus 8 is negative 4. So that means D1 is negative 4. So Tn equals T1 plus n minus 1 d. T1 is 16. N minus 1 times negative 4. So that's 16. Oh, negative 4 times n is negative. Make that a negative. Be careful. Negative 4 times n is negative 4n. Negative 1 times negative 4 is a plus 4. So the equation is a negative 4n plus 20. So how do I write down the range? It's a set of all Tn such that Tn equals negative 4n plus 20, where n belongs to the naturals. So that's how I write the range, by writing the equation now. Okay, hopefully you're understanding domain and range. Remember that an arithmetic sequence is, arithmetic is the A is first. Think of A as being the first letter in the alphabet. So think of the degree as 1. Think of linear as degree of 1. So an arithmetic sequence is a linear function. Now we have a little different one here. I just wanted to have a look at this. We have a chart. So this is 3 sticks, a figure made up of 3 segments. This one is made up of 3 segments and 2 more. So this is the first diagram, first figure, second figure, third figure, that's the fourth figure. So if we say F for figure, so the number of sticks that we have, we call these sticks or segments, don't make any difference. This is 3, this is 1, 2, 3, 4, 5, and this is 1, 2, 3, 4, 5, 6, 7, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice that you got a 3 with 2 on. So notice that the differential, or the difference, 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. So here, as you can see, this is an arithmetic sequence because the differential is 2 all the time. So you're adding 2 new sticks onto each figure. Each figure above is constructed with sticks. The number of sticks, which we're going to call Sn. So this is n, and this is Sn. But the Sn is not a t. Yes, you could say t, tn term, but this is sticks as a function notation. So this is in a function. So the number of sticks is Sn. S stands for 6, and as a function of the figure n. Complete the table, and we have n and Sn, something like an n and a tn term. So if we got the first figure, second figure, third figure, fourth figure, so this, again, this is the figure number. We can call it n. And this is a 3, 5, 7, 9 sticks. And if you go to 5, let's say, I got an extra block here, I'll do that in a minute. Is the sequence arithmetic? So the differential is the difference is 2. So D1 equals 2. And is it? Yes, because it has a constant level 1 difference. It has a constant level 1 difference of 2. So it's arithmetic. So let's find the equation. Let's find the equation. Now what about if we wanted to look at the third? What about if I wanted to put another one here? So I go that, and then I do that, go over again, and just keep going. So that becomes, you make 10 sticks. So we got 1, 2, 3. There's 11 sticks, because I got to add 2 on. You add 2 on each time. So if I wanted 5, I would get 11. If I wanted 6, I would have 13. So let's find Sn equals An plus B. So we have, oh, I got to be careful. This is S1 now. T1 is term. This is S1. S1 is 3, and the D1 is 2. So Sn equals An plus B. That's the equation I want. So let's get the equation by doing Sn equals S1 plus N minus 1D. So instead of T's, we got S's, but it doesn't, it's just a function notation. Don't let it confuse you. So the first one is 3. 3 is the first one. N minus 1 times 2. 3 plus 2n minus 2. And that gives us Sn equals 2n plus 1. And we check to see if we're right. A 1 gives us a 3, so 2 times 1 is 2, plus 1 is 3. A 2 gives us S2, number of sticks in 2 diagram is 2 times 2 is 4, plus 1 is 5, so it looks good. So let's have a look at, find the number of sticks needed to construct the figure 20. So the figure 20 is S20. S for sticks, same as T for term. So we want S20. So that means that Sn equals 2n plus 1. So the S of 20 is 2 times 20 plus 1. So that's 40 plus 1. So we have 41 sticks in figure number 20. And to keep going, which figure has 33 sticks? So that's 33 sticks is S. Is it S33? 33. So that means we have Sn equals 2n plus 1. So we need number 33. So how many sticks Sn is in? Ooh, better make that a 3. 66 plus 1. And we have 67 sticks. Which figure has 33 sticks? Oh, I didn't say it had 33 sticks. Yes, 33 sticks would be 33 sticks would be this number. So this is not right. That's the number of figures. So we have to have, so that means the Sn is, the number of sticks is 33. So it's 33 equals 2n plus. So we're looking for a figure, and the figure is the n. So the 33 is Sn. So that means 2n equals 33 minus 1. So 2n is 32. Divide by 2, and I get n to be 16. So the 16th figure will have 33 sticks, so be careful. Notice the figure is the n. I was almost going the other way, so I would have been wrong. So Sn is 33, because Sn is the number 6. This is the number of sticks. So when you use the function notation, you can get, it's better to use x's and y's, as they say, but function notation can mix you up. And state the domain and range of the S of n. The domain is always n belongs to the naturals. And the range is the equation. So the range is Sn such that, and the equation is Sn equals, where is it? 2n plus 1. Where n belongs to the naturals. So the domain is the natural numbers, and the range is the equation, which is Sn equals 2n plus 1. So be careful with the confusion here. The figure is n, so this is Sn. Because if you put, like I did, you get 67. You get number 6 is 67. So this is wrong. This is the correct way. And that brings us to the end of this video. And again, if you like my video, click the like button, subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.